Hello, and welcome to the Futurum Tech Webcast. I'm your host, Shelley Kramer. I'm a principal analyst and founding partner here at Futurum Research. On today's show, we are going to talk about a really important topic and one that is top of mind for many people these days: operational resiliency, operational efficiency, and sustainability. And my guest today is Mike Denley, who's a senior director, portfolio manager at Siemens Digital Industries Software. That's a big title. And hey, Mike. And so before we dive in, I'll give a little backstory here. So I think that I'm one of those people who's always looking for the silver linings that have come out of slogging through a global pandemic. And I think for me that one of the biggest things is that it really took operational resiliency and business continuity. Those It took those issues and it elevated them higher than ever before, because organizations realized kind of there is no these things can't be number 4 and 5 on a business strategy list, a business contingency plan list, a business resiliency plan list. They are literally at the top of the list. So we also know that what organizations are dealing with today is massive disruptions. We've got supply chain, we've got staffing issues, and we see an increased need for resiliency and the ability to adapt, to continually adapt in order to meet changing expectations. So we're seeing those things. We're seeing an increased need for greater operational efficiencies, the ability to do more with less, especially in today's current macroeconomic conditions. And if all these pressures aren't enough, many organizations are also beginning to develop or have already developed or have already planted a flag in and are working toward sustainability goals that they've established for their organization. So they're trying to do more with less without impacting the next generation. So it's a lot. And Mike and I are going to be talking today about how all of these topics are interrelated, how they differ, and what Mike and his team at Siemens is doing to help organizations achieve some of those goals. So without further ado, this is going to be a fantastic conversation. Mike, welcome to the show. I'm so glad to have you.
First, I'd like to thank you for inviting me, and extended thanks to our audience for taking the time to listen.
Absolutely. Absolutely. Well, we have a great audience, and I'm sure they're going to love this conversation. So, one of the things I love to do as we kick off these shows, I'd love to hear just a little bit about you, Mike, and kind of your career path, and then you can tell us a little bit about your career at Siemens.
Sure, I'd be glad to. I've been with Siemens for 22 years, so it's a long period of time. And backdrop is ran development processes for one of our PLM products within the teams called Team Center within the Siemens portfolio. And within that, also product management, ran the aerospace and defense services business in the Americas. So and then more recently with our industrial IoT portfolio. And what that's brought to the table is the understanding of working with enterprise, large customers in the field, as well as small and medium size, but from a development point of view of requirements and development of software products, but also how they have to be implemented and how they have to be placed into the organization to allow them to use them effectively. And then more recently with the industrial IoT, being able to collect data on its usage of both the physical product as well as the software product. And that's what makes me a little bit unique, but also Siemens is unique, because we're able to provide that whole domain set to our customers.
Right. Super important. You're the guy in the team who makes everything work. Really.
Yeah, really.
I mean, when you think we were having some conversations at the beginning of this show about our reliance on technology, right? I mean, it drives everything today, but you also have to have, the humans working alongside the technology that figures it all out together. So I went over some of these things in the introduction to the show, but I want to set the stage for this conversation. So let's talk a little bit about operational resiliency, operational efficiency, and sustainability. Let's go a little deeper into each one of those. Let's start with operational resiliency.
Well, maybe we should start with some definitions because that's a fancy word or a
There
fancy
we go.
term, right? And as we look at, and you sort of touched upon this, as we look at operational resiliency, it's really the ability to adapt to disruption. And disruption
Right,
comes in many forms, like change is one of those. And
right,
as we sort of experienced disruption in the last 3 years with COVID lockdowns, with supply chains, with now we have more the sustainability or ESG trends
right,
in the industry. These are all disruptions to a business and, more importantly, to a manufacturing as we try to put product out in the area. And along with the resiliency, it's not just the adaptation to disruption, it's also the expectation that the organization will continue to deliver and even continue to deliver with more improvements. Does that make sense? I mean, it's
right,
funny how we get in there. And that's actually related to the other term that you talk about, operations efficiency, right? And
right,
you had mentioned doing more with less. And as we look at it, it's greater productivity or greater throughput or using less resources. And as we look at a disruption in our operations, typical disruptions like downtime, that
right,
causes inefficiencies. It causes inefficiencies with the product line, with people, with resources, of materials handling, as well as the whole idea of we're expected to meet a certain product quota a day, and so a manufacturing has to look at that. And so operations efficiencies, start to look and measure, and how they measure is one of the most common ways is through OEE or overall equipment effectiveness. And that's a set of KPIs and measures that we sort of look for, how much uptime or the availability of our product line. And
right,
then also how much throughput we can make through that system, and of course quality, and looking for how we're using materials and time and resources. And you mentioned sustainability, which is sort of the name of the trend that's going on there now. I mean, we've always had manufacturing and we've always had operations for hundreds of years, but sustainability is one of the more common. And as you said, it's doing more with less, but it's really one more step. It's actually doing more with less without impacting the next generation, right? And that's
right,
what's really important. And that is related to more of a more recent trend, especially in the financial industry, fiduciary responsibility of ESG, the
right,
environmental, social, and governance. And those that are not as familiar with ESG, it's really an approach to evaluate how companies are measured against the identified social goals, right? And not necessarily the business goals, but the social goals such as CO2 reduction, right, and emissions and workforce diversity. Does that make sense? I mean, at the high level, yeah.
At a high level, yes. And I think that, to explain a little bit about the importance of ESG, the way that our team thinks about it is that, for the last decade plus, organizations of all sizes have been focused on digital transformation, right? The integration of technology into business operations, technology working alongside people and processes. It's a three-pronged thing, right? People, processes, and technology
Absolutely.
to streamline business operations, to move from an analog way of doing things to a digital way of doing things. So what we talk about here and what we believe we see happening now as it relates to ESG is, organizations are also adopting, in addition to ongoing digital transformation journeys, which is a journey it never ends. Technology continues to change. We need to continue to change and adapt. The world continues to change. Disruption happens, right? Um, but with regard to ESG, this is particularly important because what we're seeing pretty much universally and across the globe is organizations planting a flag in responsibility as it relates specifically to sustainability goals and the environment as a whole. And so organizations are making promises that by 2030 we will have reduced our carbon footprint by such and such, or by 2040, and these are our plans as it relates to sustainability. And this is incredibly important this is incredibly important to employees,
Mhm.
customers, other stakeholders within the organization. It's a business reputational thing. I mean, I think there's very much, we realize collectively that we're all in this together, and we all have an obligation to do what we can to reduce the impact of business operations on the planet, so that we have, so we have
Yeah.
a place for other generations. So when you add in you're focused as a business leader in the manufacturing space in this conversation. You're focused on business resiliency, and you're
Yeah.
focused on operational efficiency, and how you can use technology, and how you can adapt your processes and everything else to be more efficient. But then adding to that equation is this whole ESG part, the sustainability part of it. So it's a very full plate.
It is, and maybe I can share a little bit how some, they're related but different, if that makes sense,
Yeah,
because
yeah, they
that's
are.
what's really at the crux of this. As we talk about operation uh, efficiencies and sustainability, and now this ESG, they're all managing resources, right? That's common, right? How to be more efficient in their use, people, energy, and materials, as you said, right? And the short-term objective is basically like, let's use resources wisely and efficiently and cut waste. That makes
Right,
sense, right?
right,
Let me, and we like make an analogy into, let's say I have a machine, a asset on the shop floor. Let's say it's a motor, right? And it's in idle mode, right? Or not being used, or it's operating hotter or not correctly configured. It could be using more energy. So I want to
right,
make sure that I detect that and optimize for that. That makes sense, right? And
right,
so, but if we look at these longer term objectives, they start diverging through operations efficiencies and sustainability, I'll say slash ESG. And what I mean by that is, let's assume that you're using oil as your energy source. Okay, that makes sense. And let's assume that you could be using it the most effective and efficient way.
right,
Okay, that's the idea. But the current ESG trend is to use alternative forms of renewable energy, like solar or wind or
right,
hydroelectric. And this is what puts it at odds or differences. Does that make sense? And so we
yeah,
need to rethink of how we're using natural resources, and as we start looking at alternative renewable ways. And
right.
so we all
Yeah,
need to reduce resource consumption, but we also need to be able to understand how to use resources smarter.
right. Absolutely. And that is something that we will, I believe we're at kind of the beginning stages of really focusing in on this as it relates to ESG. And I don't want to confuse anybody. ESG encompasses sustainability as part of ESG.
It is.
Okay. So
Yeah.
they're not two separate things.
No.
Your ESG initiatives, your sustainability initiative, they're the same thing. Okay. So there is something, however, that plays a large role in an organization's ability to deliver as it relates to operational resiliency and
Mhm.
operational efficiency and sustainability. And that is the industrial Internet of Things. So let's talk about that a little bit. Where does the IoT fit in all of this?
Yeah, that's a great question, and they do have a common sort of denominator, right? The numerator may change, but the denominator is to being able to collect data. Usually, that data is collected via sensors, and allow us to measure and predict trends. Not only
Right,
for one object, that motor I was talking about, or an asset like a motor, a pump, or generator, but really the whole production line. And it starts at the manufacturing, but it could be a whole interconnected system of devices, like the manufacturing line or a distribution center, or a more complex, like a train or a building, right? And so as we get into this, right? And so this is where we start connecting IT with OT and this IT OT convergence. And what is key for, let's say, operational resiliency and efficiency is this ability to collect and measure not only the process data and the device data in near real time, right? And that includes like temperature and status and humidity and stuff. But we couple that with material and product flow, because part of the resource usage is moving that material, moving that product through the line, right, and ensuring that operations is efficient. And so this collected IoT data then can be analyzed. That's what's really important. But what's more important when we collect it, it's got to be in context. Just to look at data without understanding what's actually happening on the manufacturing floor, it doesn't provide the entire picture. So we need to have that data analyzed in context and within to identify this trend or event. And one example is like to get people's heads around this, condition monitoring, right? The motor can be on or off. That's a condition. We can detect that. Or a process threshold, like temperature. Like if we're doing resonance, right? Maybe the control point is greater than 80 degrees. Yet that's another condition, but that may indicate that we need to service the motor or get into the heating element because it's too hot. If that makes sense, right? So we are using IoT to optimize the operations and gain efficiencies, but also to reduce this downtime. Does that make sense a little bit?
It absolutely makes sense. It's super important. So you touched on this already, but the IIoT generates a boatload. That's a technical term, by the
The
way, of
boatload,
data.
yeah. About 50. Yeah.
Of data, a metric ton. It generates a lot of data, and that presents sometimes a very big challenge for organizations. So let's talk a little bit, if we can, about data analytics data analytics capabilities and the role that they play here.
Yeah, before I start, I'd like to just to make one thing. As this data, you're absolutely right. As we're collecting data, one of the statements is made sometimes is that resources are finite, but data is infinite, right? We have a tendency to collect data on all aspects, thinking that it's better to collect data, even though we're not currently using it. So
Right.
it's like, why am I saying this? Of course, data is important, but there is smart data management as well, right?
Right.
And you think about collecting more data than it's needed, well, that has to be stored on a disk drive. That means that I'm using materials for that drive, and I'm using energy to power it. So
More
just
resources.
more resources. So
Right.
as we get into analytics, we have to understand why we're doing the analytics, but also what data I need to do that analytics. And we have a tendency to use more data. And you're probably more aware of this. Data is growing at this exponential rate. And one of the stats I recently came out: 90% of the data has been generated in the last 2 years. Isn't that interesting?
It's
Right?
crazy.
It is crazy. And then the other trend that's part with this data, and I'll get to analytics here in a second, but this is important, is that the ongoing trend with IoT is the shifting to cloud-based data centers, right? We have the hyperscalers out there, and companies think that's part of the sustainability answer, and it is. Why? Because instead of having these siloed data centers at each company by company by company, we are actually able to combine that and have reduced overall IT footprints, which is actually reducing energy and carbon usage and emissions. But at the same time, there's also a need to think about not putting everything in the cloud, but keeping some of that data analytics at the edge and using
Right.
other techniques like closed loop digital twin. And I know we'll probably talk about that a little farther in the conversation here, but
We
let's talk
will.
about, now I generate all this data, right? I generate this data. Now, what can I do with that? Of course, we talked about, I collect data, I want to measure something. And what I start doing with analytics, I start trying to understand the behavior of my assets or my motor or my generator or a plant line. Here, even though we're talking about manufacturing, we could be talking about the operation of a product in the field, like a wind generator or windmill,
Right.
right? And so it does, even though we talk about manufacturing, it's easy to understand, but it's really the complete life cycle here. And so we start building these models of behavior, and people will know that as, oh, that's AI, artificial intelligence, or ML, machine learning. And what
Right.
we're trying to do is build a simulation of the behavior of that device or that system. And then we use the IoT data to optimize that to create a set of rules or conditions, right? And then we use real live data in that model to predict behavior like a possible breakdown. And we already said breakdowns are not good for operations efficiency. They're a waste of
Right.
resource, right?
Right.
And so that data with the analytics can tell us the right time to perform maintenance,
Right.
like which is predictive or optimized maintenance, right? And the same model concept can predict energy usage, right? Remember I used that, the motor is running hotter, right? It's
Right.
at a higher temperature, or it's vibrating more. Then we know the motor is using more energy than necessary. End of story. We know that. So data
Yeah.
analytics allows us to generate new insights at much faster rate to improve this efficiency and quality. And of course, we talk about bottlenecks and manufacturing and maintenance costs, right? So
Yeah, and I think that, the one of the key things here is that across the board, what we hear from customers, from manufacturing organizations, is that that data challenge is a very big challenge. And, again, we have massive quantities of data that we're collecting that's growing at an exponential rate. It's going to continue to grow at an exponential rate. We're collecting data from, of hundreds and thousands and millions of sensors, right? Maybe
yeah,
not all in one organization,
yeah, yeah.
but it really is, and that's bringing into focus the importance of edge computing and those capabilities. But in reality, knowing what to do with that data, having a data management capability, having the ability to actually use the key parts of that data to do exactly what you want to do, that's the biggest challenge that a lot of organizations face today. So I think that um, to me, knowing the value prop that Siemens brings to the table, that's a really important part of this equation.
Yeah, I agree with you. And the use of the analytics of data, being able to collect data, understand which is the smart data, and the behavior models, as whether we're in an engineering process or a manufacturing process or in the field execution operations process, the idea is to shift left the discovery earlier in the cycle. And as we know, as we shift left in the cycle, we're actually reducing the number of steps after that fact. We're actually
Right.
reducing resource usage and meeting these sustainability goals at the same time. That's it.
Right.
That's what's interesting, right?
Yeah,
So
and super important. So, well, that leads us to, I know you touched on it here just a minute ago, but digital twins. Let's talk
um,
about digital twins and why this is so important.
yeah, this is, I just mentioned about shift left, right? The whole
Right.
idea and what the digital twins play into that shift left earlier discovery. If I'm finding out a requirement's not going to be met earlier in the design cycle, or I find out that the motor is running hotter, I can fix it earlier than having it break down. And so a digital twin, by definition, just a high level, is it's a virtual representation, something in logic or inside the computer of a physical object, like a machine or a motor or a pump, right? And it has these behaviors, but it could be a more complex layered system, like a system of systems, like a representation. A train would be in this, or a building. You can see there are many in a building. There's HVAC systems, right? There is the
Right.
motor and locomotion and energy usage, and so there's these layered items. So the train itself is a could be a digital twin, but also everything within it is also layers of digital twins. And so this is
Right.
what's interesting. And so you get the system of systems. And we talked about these models, these ML models, machine learning models. And one way of thinking of a digital twin is a set of related behavior models. They're just layered up, and some of them interact, some of them don't. And technically, digital twins have been around for a really long time, even though they become more relevant now than ever before. One could argue that a CAD model is a form of a digital twin because it's a virtual representation in via a geometric software of a physical object, right? It's the motor, but it's a CAD model of that motor, right? What is different today than just saying, oh, I've got it in the CAD model, is that we're able to collect this data and measure it in near real time. And so
Right.
this usage data via this, industrial IoT, as we talk about it, we can relate it to the digital twin. And now we can have a live virtual representation of that product with its behavior. And not only that, we can actually, since it's live data or near real time data, we can actually check the expectations or the assumptions we made on the requirements
Right.
within that operations, and then start looking at is the product design correct? Are the requirements correct? Was it manufactured correct? Was it service correct? And that's what the value of the digital twin allows us. It allows us to collect this data, place it in context, and then apply it back to these behavior models. And when we do that, it's a closed loop digital twin, feeding back real life data to optimize the model and sort of predict or to validate your assumptions of requirements or operations, is a part of that. And that's what makes it interesting, because now we're able to predict behavior under a variety of conditions. Because in a testing world or a real live world, we don't know when there's an energy shortage, right? We don't know if
Right.
we're, and so now we can predict that.
Digital twins are a big deal.
Yeah, I think so. And closed loop digital twins are even more important, and from my point of
Yes.
view, right? So
Absolutely. We are on the same page there. So let's then wrap it up and talk about, so how does the IoT, data analytics, and digital twins help as it relates to, I mean, you might have touched on this a little bit,
yeah,
but
a little bit. Yeah.
with regard to operations efficiency and sustainability, we know part of it is about resource management and
Yeah,
monitoring and that
yeah,
sort of
yeah.
thing. But any thoughts on that over and above what you've already shared?
Well, again, digital twin is this virtual representation that has a series of machine learning or models to it, right? We're
Right.
collecting IoT data, but one of the things that we're also doing is collecting other forms of data from other systems like PLM systems or ERP systems or MES systems. And so now we're not only able to identify current usage, because that's what we've been talking about, but also other insightful relationships like quality of supplier parts, because I don't want a poor supplier part, right? Or an infield operations. We are predicting trends or outcomes. And again, this closed loop comes back into that. So
Right.
digital twins are relevant across the entire life cycle, but have specific value when we talk about product engineering or manufacturing or operations. And the whole idea is to use these closed loops, digital twins, to identify non-optimized operations and resource usage. And we've been focusing on natural resources like water and energy, but it also applies to materials and time and people, right? And that's where the
Right.
ESG comes in, right? Because it's all encompassing. It's not just the natural resources, it's actually looking better ways of doing it. And so as we apply closed loop digital twins and AI/ML within this ESG space, we can predict and track the carbon footprints starting at the design. That's the interesting, even before the first prototype or product components are being manufactured. That's the difference. And
That's
then,
exciting. I
yeah,
mean, it's tremendously
yeah,
exciting,
yeah,
right? I
yeah,
mean,
yeah. Yeah, and then what's further is that once that first product is built and actually in the field, we
yeah.
can then take what we have planned as part of the engineering, and then we can actually monitor the real product and track its life across the supply chain
Yeah.
and in the field against service life cycle. That is pretty powerful.
It is really powerful, and it's all about data, right?
Yeah,
I mean, that's
yeah, it's funny. It's all about data. You're right, but
yeah,
yeah,
it is. But when you can, and that's really what I think the foundational premises of digital transformation is, right? I mean, it is data, is being a data driven
yeah,
organization is
yeah,
the key to success. And but also knowing the role data plays,
yeah.
knowing the role technology plays, the right technology solutions that allow you to gather and use and test all these things we're talking about all work together, and data is the lifeblood of any organization.
Yeah, I just my only qualifier to that, not that you're wrong, is
Yeah.
is having the right data. Too much
Oh,
data is not
absolutely.
the answer, and then
Absolutely.
having smart data management along with that. But you're
So
absolutely
important.
spot on, right? So
Yeah, so important. So, one of the things I always ask my guests on this show is, do you have any case studies or customer examples about that you can share with us about how Siemens is helping customers navigate these challenges?
yeah, Siemens, as a large company, has hundreds of examples across
Right.
our accelerator ecosystem across
Sure.
multiple industries. But let me share a couple that I think would, be a strike, chord with our audience. We're helping several soft drink bottlers boost resource efficiency. Collecting more than I think over 100 data points just on energy consumption and I almost 2 dozen data points on water consumption, key resources, right?
Wow.
And these are being updated regularly, like every minute, and
Yeah.
monitored via dashboards and alerts. And the whole idea is to reduce energy consumption while improving system maintenance and, of course, prevent energy loss, right?
Right.
And a bottler, we talk about tens of thousands of dollars when that line goes down, right?
Right.
And so there's a cost to that. And then when we talk about energy, another example is in the wind energy field. We're working with a large service and maintenance company of wind farms using closed loop digital twins. Now, wind farms are one of those alternate forms of energy, so
Right.
important in sustainability. And so we're using closed loop digital twins and IoT feedback not only to reduce operating costs, because that's part of sustainability, and
Right.
increase asset availability, but what's more important is to increase energy yield why we're extending the remaining useful life of gearboxes in the field. You think about a wind turbine, there's a gearbox that keeps the blades running.
Right.
And, extending that life reduces the carbon footprint, if that makes sense. I don't need to build another gearbox. I can
Right.
reuse the one I've got. And that's part of the circular economy. Does that make sense?
Right.
Which is something we haven't talked about, and I don't want to
Well,
confuse anybody, but yeah.
but an important part of any sustainability initiative.
We
Yes.
have to understand, especially in product design,
Yeah.
because the re-life now, before we talked about retirement of product, right? How to
Right.
salvage the product. That's no longer. Now it's a reuse, right? It's a
Right.
second economy. How do I, take that same product and upgrade it in the field possibly for a new item? One of the other items I think is sort of interesting in this sustainability is a different type of manufacturing, sustainable fish farming, right? Which is
Right.
supporting the smart food production. We're still leveraging sensors and IoT data and this AI-based analytics, but we're doing this in this aquaculture area in a closed loop system of a controlled
Right.
environment with multiple levels of water treatment. Think about how clean that water has to be, and with solar energy. So we get this complex set of systems of systems. And the whole idea of monitoring that in real time is to ensure proper nutrition of the fish,
Right.
not over feeding them, smart water management by reducing waste and pollution. And of course, the ultimate goal is to have a productive, scalable, environmental friendly operation at the
Right.
end of the day. Right?
That's very cool.
Yeah.
So, as we wrap up what I knew was going to be a great conversation, thank you so much for that. Um, what I want to ask of you is, so for someone watching or listening to this conversation who
Yeah.
says, okay, everything that Mike said makes perfect sense. I'm not there yet.
Yeah.
Where do I, where do I start? What do I do? Where should I go?
Yeah.
So, what's your best advice for that person?
Yeah, well, there's lots of resources, but they're one of the ones I would start with is at Siemens.com, but slash sustainability. So
Okay.
Siemens.com slash sustainability. Now, why there? Because we discuss openly how we are helping our customers, and so other customers or can look at that and say, that's like me. How do I identify with that?
Right.
But more importantly, is how Siemens is achieving net neutrality because we're a manufacturer too, right?
Right.
And so we have a dual responsibility, not only to help our customers, but also as we produce product, that we're meeting those ESG and sustainability goals within that. So that's my first place I would start. And they do a really good job. They talk about what's happening in the marketplace, what's happening around the world at the global consoles, and what the commitments are by governments and such. The other place I would start is, gee, I don't know much about industrial IoT. Where do I
Right.
go? There is Siemens.com/Mindsphere, MINDSPHERE, and we talk about industrial IoT and when is it time to do it yourself and when is it time to buy, and we look at related solutions, and so we're pretty open about that. And then another is, we have an ecosystem, and part of Mindsphere is mindsphere.io, and we talk about solutions and partners and specific customer use cases. So
Right.
I think those are three good starts because you need to do your research, right? And I think
Right.
Siemens is a really good source of information because we believe in openness of our ecosystem and our products. So that's a good place to start.
Right. Absolutely. Well, great advice. Mike Denley from Siemens, thank you so much for spending time with me today and sharing some of your gray matter. I knew it was going to be a great conversation, and I'm sure our audience will agree, and we'll have to do it again soon.
I appreciate your guidance here, and it's been good. Thank you very much.
Absolutely. Absolutely. Well, with that, that's a wrap for our show. Thanks to our listening audience or our viewing audience for, as always, for being a part of these conversations. And I will include some of the links that to the references that Mike mentioned in the show notes so that you'll have those easily accessible. And with that, it's a wrap.
Thank you very much. Bye bye.